Hi, my name is Ginny Catania, and I am a professor here in Geosciences at the University of Texas. And I'm a glaciologist, so I study how ice sheets work. In particular, I'm interested in how ice sheets flow in response to changes in climate. And my broader research program is really trying to understand how climate influences ice sheets separately from how ice sheets behave on their own, because we know ice sheets behave in really highly unique ways, nonlinear ways, that are irregardless of climate change. And so trying to parse out that kind of signal from a signal of climate change impact to an ice sheet is a tricky thing to do, and that's where a lot of my research is focused. And lately, I've been really looking at the marine margins of the ice sheet, so where the ice sheet meets the ocean. And it's been a really rich environment for me to work in because there's both the marine environment, the ice sheet environment, but also the sedimentary environment at the bottom of the ice sheet. So looking at all those interactions has been a really important and enriching process for me. And this is my student, Sophie, and she's going to talk a little bit more about her own particular research.
So my research is focused on understanding how marine terrain glaciers interact with climate and the bed topography and the Greenland ice sheet. So we know the ice sheet's been losing mass more rapidly over the past 2 decades, and some of that loss is attributed to the thinning and retreat of Greenland glaciers. So understanding how they change is important for predicting future behavior in ice sheet models. I specifically use remote sensing techniques for my research, which means I use a lot of data from airborne and satellite sensors. A lot of my work has been using satellite images of the surface. For example, these images from the Landsat satellite are taken on the same place on the Earth every 2 weeks, so they allow us to detect changes that are happening to these glaciers, such as the retreat, how quickly they are flowing, and if they have lakes on the surface that are draining or filling. These observations are crucial for understanding how these glaciers will retreat and melt in a warming climate, and how the shape of the bed of these glaciers are located in affects their retreat.
So this work is really important because we need to understand how glaciers are changing in response to climate in order to better understand how they work in general. If we know how to build a better glacier model through an improved understanding, then we can make better predictions of sea level rise. We know our planet's warming. We know we have way more CO2 in our atmosphere than we've had in the last 400,000 years. So we expect to have a lot of sea level rise in response to that. The problem is really, when is it going to rise and how much is it going to rise? And so that really hinges on our understanding of how glaciers and ice sheets work. And our work is really aimed at trying to reduce that uncertainty so that we can make better predictions for policymakers and people who live in coastal communities. So it's not like either of us really knew we would be glaciologists when we were little kids. I didn't even really know that glaciology was a field that you could pursue. I never would have imagined someone would pay me a salary to study glaciers. But here I am doing glaciology. And so you might ask, how did we both get into this? And I think we both had kind of similar paths in that we were both quite interested in environmental science and trying to save the world. And we both went into degrees that were not the best choice for us. Mine was environmental science.
Yeah, I started out in environmental engineering. I'd always been a little environmentalist as a kid, and I wanted to grow up and save the planet. And I thought environmental engineering would be a cool way to do that because I was kind of interested in math. But once I got into it, I realized I wasn't really into chemistry and biology, so I turned to earth sciences, and I started taking a lot of different classes in that field, like geomorphology and remote sensing. So I learned a lot about how I could apply what I was good at, which was understanding different earth systems. I really liked working on the computer, which is where a lot of my research is done. And I sort of found glaciology. I was able to connect my love of the environment to my love of remote sensing and better understand how glaciers are affecting our planet.
And so for me, I thought I would go into environmental science, and then I didn't like that, and I thought I would go into math, and I didn't like that, or more specifically, I didn't really like the community associated with math. And so I went into geosciences because the people there are really outdoorsy, and I fell in love with being outside, and I did a lot of field work in my early career at college. and through my PhD as well. And that really, for me, cemented my love of the field. And after being out, especially in Antarctica, I got a sense of how phenomenal ice sheets are, and I started to fall in love with the science as well. And so a lot of people have asked me, how is it to be a female in the field of glaciology when it's really a male-dominated field? And I would just say, if you want to do something, you should just do it. That's always been my philosophy. And don't really think about being the only, person out there that's interested in your field. Just do whatever you find really interesting and do what you're good at. So I still use a lot of principles of mathematics and physics, things that I was really good at, still in the field of glaciology, just applying it to something that I'm super passionate about. Ice sheets randomly and being outside. So I guess the point is that you should do whatever that you want to do. I don't think people should be held back by how they look or what they might look like. They might be embarrassed about doing something that they may not be perfect at doing. Just go and do what you're really passionate about, and you'll find that you'll eventually be really good at it. And our field of geoscience is pretty heavily male-dominated and very white, but it's really changing and opening up. There's a lot of changes that are happening across the international community in geosciences to really embrace a lot more diverse viewpoints, and then people are recognizing the advantage of that. So if anyone out there is interested in the earth sciences and being outside and exploring the world around you and trying to be able to explain the world around you, then I would encourage you to explore the field of geosciences.
My advice to anyone who doesn't really know what they're interested in or want to figure out what they're interested in is just to ask a lot of questions. Maybe you find an expert in a field that you think is interesting, or you just go on the internet and you start searching things. The more questions you ask, the more you'll find out, and then maybe you can even get into some research when you get into college. That's how I started, is I wanted to know more about how glaciers interact with their environment. So then I started asking our glaciologist questions, and she said I could start doing some research. And so that's how I sort of got started in my graduate studies.
The other thing you could do is pick a college to go to that has a pretty big research program, and that's not always a choice for everybody. But if you have a college that, like UT, has a lot of researchers, there's just going to be a lot of breadth in what people work on, and so it gives you a lot more choices in a sense of what all the options are that you can pick from. When you go to a smaller school, you might not get that breadth of options that you can pick from. So anything you can do to get some exposure to all the different sciences that are available to you allows you to kind of hone in on your interests more specifically.